So that's with permutations. And this I just pointed out also. The book doesn't point it out, but I feel better doing that. If instead you allow replacement and the order does matter, then you just do n to the r. That's what I'm trying to show you here. So if you have n possibilities and you're arranging r of them, hold on, let me make this bigger. In that case, if you allow repetition, you would have n to the r. That's like the first one we did. With the passwords, you know, there were 5 digits, but we allowed repetition. We got 5 to the 5. Same idea. But no repetition means you do permutations. Again, here the order does matter. Okay? I mean, maybe not today, but next time we'll see what happens when the order doesn't matter. Then you get what's called a combination. And again, this is really just by the, the basic counting rule. Okay, that's good. All right, so here's another example. So let's say we have some kind of race, you know, a race on the track, you know, running or whatever. Okay, there are 8 people here. Okay, there are 8 people, and they're running in the race. And you know, in a race, you know, like the Olympics or something, the first one that finishes gets a prize, the gold medal. The second place, the one that finishes second place, that's the silver medal. And the one who finishes third, their medal is bronze. And I don't think they give anything after that. I don't think so. So now the question is, okay, well, among these 8 people, right, how many ways can we give away those 3 medals? In other words, how many ways can someone finish first and get the gold medal, someone finish second and get the silver, and third also? Well, clearly repetition is not going to be allowed, right? And why is that? Well, because, you know, you can't have someone win first and second at the same time. I hate to say it like this, but it's kind of I think that's kind of obvious. Okay? And of course, order matters. You know, if you're going to win, that should be kind of obvious too. The repetition is not allowed. You know, you can't win more than 1 medal, and the order does matter. So, okay, so our answer then, how many ways will these 3 medals be awarded? Well, that's permutations. P of 8, 3. Okay. That's P of 8, 3. We have 8 people, right? And you could think of this as arranging 3 of them, where the first one in the list gets the gold, second gets silver, third gets bronze. Okay. So P of 8, 3. And now by our formula, by that factorial formula, that's what I'm writing over here. You know, it's n factorial over n minus r factorial. You know, if you go back, let me over here. Or over here, I guess, if you want. Now, I did write out the calculation why we get why this works. That's what this is showing you. You can see 8 minus 3 factorial, and then you have cancellation. So that's why the formula actually works. That's what I'm trying to show you here with the formula, why this formula is equal to this. It's just really cancellation. So, and this should make sense by the counting principle anyway. There are 8 possible choices, you know, 8 people that can get the first medal. There are 7 people that can get the silver. And there are 6 people remaining that can get the bronze. So we have this. And here I just said, okay, what if there are 10 people now instead? Well, it's the same idea, except instead of 8 here, you have a 10, and we get this. So that's the only difference. Again, I didn't write this part out, but you know, the idea is similar. Essentially, you're just you know, replacing 8 by 10. So same idea. Okay, so that's one example. Okay, so that's good. Any questions on that? okay? Well, here's another one. So here we have a 4-person committee, right? You know, we're making a 4-person committee for whatever, I guess, okay? There's 16, you know, we're selecting from a 16-member board of directors for a nonprofit organization. So basically what this is saying is there are 16 possible members that can take office in any of these 4, okay? That is, we have 16 people. We're choosing 4 of them to be on this executive committee. So the first person we choose, or, you know, is elected by whatever way, becomes the president. The second person becomes vice president. The third person becomes secretary, and the fourth person becomes the treasurer. And basically what we're going to ask here is, okay, well, how many ways can this happen? How many ways can we do this? Well, I wrote it down here, but even if I didn't write it down in the slide, it should be kind of obvious that repetition cannot happen. You know, you can't have someone holding more than one office. Not only that, order does matter. I mean, that's just how elections are. And I even said that the first person chosen is president. The second person chosen is vice president. So there is order there. Okay, so because of that, the number of ways, right? We're looking for basically permutations here. You know, it's an ordered list with no repetition. So our permutation, we're choosing from 16 possibilities. We're choosing 4 elements from the list, or in this case, people. So we get this. I mean, even by the calculation alone, you should be able to see, oh yeah, this does make sense. You know, look at what it's telling you. 16 choices for the first person, for the president. And once that person is chosen somehow, there are 15 people left over for vice president. And it's 14 for secretary and 13 for treasurer. By the counting principle, you multiply. That's how we get this. Excuse me. This is what we get for our second example. Okay, so now we just basically calculated different ways involving permutations. We didn't calculate any probabilities, notice. No, we didn't ask, you know, what's the probability that this person becomes president or whatever. In this example, that is. Now we're going to do some probability. So let's get back to that wonderful password idea. A password example, that is. I know I changed it a bit, you know, so that the numbers are easier to manage. Suppose now we're making a 4-digit password. So if you want, in that bank example, or I think on apps they do this too. I think like certain apps do this. You have to make like a 4-digit PIN, like two-way access or something. But let's suppose we're making a 4-digit password, okay? There are 10 possibilities for each digit, you know, any of the 10 digits here. Now, we want to select one at random, okay? One of those passwords, that is. Okay. Well, what's the probability that the password we choose has no repeated digits? The password we choose has no repeated digits. Okay. So here I basically go through how you get the sample space, how you get, you know, a number of outcomes we're looking for. For the sample space, we're looking for all possible 4-digit passwords, right? You know, including repetition. In a password, order always matters. So we have order matters. The sample space, we're allowing repetition. We don't have to have repetition, but we allow it though. It's still a possibility. So the sample space, the total number by the counting principle is 10 to the 4. I'm also just using that n to the r on a previous slide. Because for that case, we allowed repetition and order matters. So in this case, our N, the number of possibilities, is 10. R is a 4-digit password, so R is 4. That's how many possible passwords there are. Well, which ones do not have repetition, right? Well, that's what the permutations are. That's what we're looking for, and that's what this is. These are the ones that don't have any repetition. So these are the desired outcomes, the one corresponding to the event that we choose a password where there's no repetition. So our probability then is going to be this, the number of desired outcomes divided by the total number of outcomes. We get this. So assuming my calculations are right, which I think they are, we get this. That's fun.